Alright guys, we're still talking about the Pfizer building, 16 floors on top of an existing roof where the columns directly underneath the roof buckled, as we can see here in the picture. What we know now is that they placing supports or shores in the whole building to stabilize. We also need to find a solution for this problem, and we're going to do this in this video because nobody wants to have these kind of shoring in their living room, of course. Here we can see shortly the solution, but later more. We know now that the engineering firm proposed reinforcement on the sides of these columns and probably also in the floors below. Here we can see an image how that reinforced situation would look like. So this is the white flange steel and there are reinforcement plates welded on the sides. And if you look at the software, I added the two situations in the software. So here's the unreinforced column. And then important in this situation is to take a look at the 4.35. So that's actually the strength of the shape in the weak direction. So 4.35. So now let's take a look at the reinforced situation. So the H-shaped beam with the plates welded on the sides. And then we see the number increase to 71. We see that this column and the weak axis became 16 times stronger. So this tells us that it was really important to do the reinforcement before adding extra floors. In my previous video, I also checked the box shape profile in the model and we saw that it complies according to standards. I want to add one more thing about white flange steel. If we take a look at the way the columns failed, they buckle and they directly lose their strength. So these columns don't do anything anymore. If we take a look at these columns here, these are failed square-shaped columns, and what we see is that they actually just became a bit shorter. But the way of failing is much less dangerous than we see with the white flange, and especially the more rectangular shaped columns. So we already saw the way how they are shoring the building now to make it safe and stable. Also in another video I showed you that just placing these supports on just a few floors put a huge risk on this connection here, and I showed that in a previous video. 200, so the columns might not be at risk anymore, but the beams are. So that's why they need to place these shores over the whole height of the building. So really place the shores from the top completely. Yeah, here we see them. Here we also see some in the floors above, but they have to place them completely down towards the foundation. So there's no risk of any new failure. So if we want to know how to fix it, we also need to know how the situation actually is now. So we just talked about the shoring already. So from the top to the foundation. And in my model, I also created a situation that is slanted. We can see here. So this side of the building sagged a bit downward. And we can see what that does to the building. Because if there are slanted profiles in a building, that directly means that there are also horizontal loads in the building, and the building is not designed for that. So here we see the vertical load out of one line of columns, and here we see horizontal loads. These loads just showed up because the building sagged a bit downwards. So what is really important that they also connect the building maybe extra. So beside the shoring, they also need to put extra connections to the neighboring buildings. I can show you here that there were no additional horizontal reactions. That's just because the building sagged a bit downwards. So now we know that it's not just vertical loads anymore in this building towards the foundation, but also there are extra horizontal reactions. Okay, there are two ways to repair the situation, is to get all the floors off and start over again. If we take a look at this image, we see that the building consists out of welded steel frames. So there are no bolts included, which means that if we want to remove it, it has to be cut. So all the work that has been done can be thrown in the garbage. Also the concrete floors on top of the steel frames have to be demolished and removed. So reusing it is not an option anymore. So they have to take it off completely and put a new frame on top. The other solution that we have is jacking up the situation by hydraulic jacks. Here we see an example of hydraulic jacks here as well. And these jacks actually have so much force that they can push a building up or a bridge up. So this is nothing new. If you look a bit closer, this is the jack. there's a steel plate on top to push this piece of equipment, in this case, up. And here they're trying to push a bridge outwards. So it's a proven method. So in this situation, I added the jacks in the model. The jacks are the pieces here in yellow. So what's necessary? They first need to add a frame. I would say a moment frame here on top where the buckled columns are. So first remove these buckled columns, then a moment frame from one side to the other, which make this profile stable actually in one direction. And on top of this frame, they can put the jacks. And what's important to know is that when they want to jack up a hanging floor, so imagine this is the hanging floor, we want to introduce a vertical load upwards. It always goes a bit in a bended movement. And for that, it's better to use these tilting saddles. That means actually that there's half of a steel bowl inside the head of the jack, and this piece, the head, can then actually move in the direction of the floor. So the jack remains vertical and the head moves with the shape of the floor. And the other risk that they have is that there are horizontal loads here in the floors, so they really need to be aware that these steel beams are connected in the other building, in the neighboring building, this one as well. And then they could use this design to push the building bit by bit upwards. So once again, there are horizontal forces now, not just on the top floor, but also here. But in all the floors actually above the buckled columns. All these beams, all these floors have to get better connections into the neighboring buildings to make sure that the building still cannot fall. Because when we're gonna lift the building with these jacks, some unexpected horizontal movement can show up, and this connection never can take these horizontal forces that we saw before. So what's good to mention as well is that this frame gonna be permanent. So we have to push the building on the location where the columns are buckled. All the columns underneath have to be double checked again and be reinforced before they start jacking this up, because some extra loads can be introduced. So the weight of the building is around 8,700 kilonewton. So that also means that this jacking system needs to be able to push the building with that same load upwards. So let's take a look at this video again where we see the buckled column. So this piece needs to be renewed. So a new column, a reinforced column. On top of that, a jack. And then here also needs to be, this piece of beam also needs to be reinforced. Actually, it needs to be as strong as this column here. So actually this becomes one long column. And that is because this beam doesn't have any support on the side. What we see here are just cable trays. In my eyes, the developer will be way too proud to say, okay, we admit our mistake and we take everything off. They will rather say, we forgot to add reinforcement, but we corrected our mistake. All right, let me know what you think about the solution, and I see you in the next video.